Alright, we're on number 5. I'm going to have to crowd my work, which is never a good idea. I'm going to color code them to make them clear, and I'm not going to write after B anymore. I'm just going to know that you know that they're dependent. So with the probability of getting B, this is like a Scrabble situation. I've got the words that spell banana, B-A-N-A-N-A, and I'm flipping them over, mixing them up, and randomly picking a letter. The probability of picking the letter B, since there's only one B and 6 Scrabble tiles, would be 1/6. Then without replacing the first tile, so the B is gone, I'm not going to keep marking it. I'm just going to, you see my little dot hovering over the B, I'm pretending that's not there. You can cover it with your thumb. To get an N now, there would be 2 N's, but only 5 tiles because the B is no longer there. 2 of 5. 2 out of 5, I should say. 2 of 5 means something different. The 2 and the 6 have a common factor of 2. So that becomes a 1 and that becomes a 3. And I get a probability of 1/15. 1/15 is here and here and here. There's 3 of them. I'm going to cross out this one. Number 6 says probability of B then A. So probability of B multiplied by probability of A after B. B was 1/6. We already did that in the last problem. And then that same B is gone. Now in A, there's 3 A's. 3 favorable outcomes out of the 5 remaining tiles. Remember that B is no longer there. So 3 out of 5, 3/5 for a probability of A. It's more than 50-50 on that. The 3 and the 6 have a common factor of 3. 3 divided by 3 is 1. 6 divided by 3 is 2. When you multiply, you get 1/10. So I'll cross out my favorite 1/10. Problem number 7. The probability of N then B would be the probability of N multiplied by the probability of B after picking N. The probability of N, there are 2 favorable outcomes of the 6 tiles. So 2/6, which I'm going to write well, no, I don't want to simplify it yet for a reason. Okay, now here's where students make an error. You don't cover up both of those N's. You picked a tile and it was an N. You can cover up this N with your thumb or this N with your thumb. It doesn't matter, but only cover up one of them. You picked one N. One N is still in the pile of Scrabble tiles. Just to make it clear, I'm going to cover that one up so it's no longer there with my thumb. And then the probability of getting a B after picking one of those N's, well, there's one B and there's 5 tiles to choose from. So 1/5. The 2/6 becomes 1/3, and you end up with 1/15 for the probability for number 7. 1/15 right there. Alright, I'm going to erase my thumb. All you have to do is lift up yours. And let's look at number 8. Probability of N multiplied by the probability of A after N. The probability of an N is 2 out of 6, so 2/6. If I cover up one of those N's, there are three A's left out of 5 tiles. So this is 3/5. The 3 and the 6 have a common factor of 3. This becomes a 1 and this becomes a 2. And of course, 2 halves is 1 whole. So this simplifies a lot until you end up with, in simplest form, a probability of 1/5 for number 8. I'll cross off that 1/5. Number 9. Probability of A then B would be the probability of A multiplied by the probability of B after A. A is very likely. Half of the tiles are A's. 3 tiles out of the 6 tiles. 3/6, which is 1/2. Now, don't forget, you're only covering up one of the A's. It doesn't matter which one, but only one of those A's is missing now. The probability of B will then be 1, because there's only one B out of 5, 1/5, not 1/6, 1/5. And then that product is 1/10, so the overall probability is 1/10, which is right there. Number 10, probability of A then N. Probability of A multiplied by probability of N. Probability of A we've already said is 1/2, and then if I cover up one of those A's, there are 2 N's, so 2 favorable outcomes out of the 5 remaining tiles. So 2/5. You see the 2 halves cancel, and I'm left with 1/5. So I'll cross off another 1/5. Trying to mix up these colors. Number 11, probability of N then N. Probability of N multiplied by probability of N. The probability of getting the first N is 2. There's 2 favorable outcomes out of 6 tiles, so 2/6. After I get the first N, there's only 1 N remaining and only 5 tiles remaining, so that's 1/5. Of course, the 2/6 simplifies to 1/3, and so the probability is 1/15. Number 12, probability of A then A. Probability of A multiplied by probability of A after we pick an A. Probability of A is 3/6, or 1/2. But then pretend one of those A's is no longer there. You have 2 favorable outcomes, 2 A's remaining, and 5 tiles remaining, so that's 2/5. And the 2's will cancel. 2 halves is 1 whole, and you get another 1/5. We'll cross off the final 1/5. 13, probability of B then B. Probability of B multiplied by probability of B. The probability of getting the first B, there's only 1 B, so 1 out of 6, 1/6. And then the probability of getting a B after we get that first B, if you've got this B covered up with your thumb, how many favorable outcomes are there? Of these 5 tiles, do you see any other B's? No, so there are 0 favorable outcomes out of 5 possible outcomes. And if you want to multiply those, you can go ahead, but 0/5 is 0, so anything multiplied by 0 is 0. You get 0/30 if you multiply across, but that's 0. And this one often throws students, but this makes sense that it would be a probability of 0 because you can't pick B and then get another B unless you replace it. There was only 1 in the first place. There's a probability of picking the B the first time, but if you don't replace it, there's exactly 0 chance that you're going to get another B. And so it makes sense that this one would calculate to be impossible. Now I'm going to see if I can find a clever way of remembering all these for the next slide. I got the 0, the 5ths, the 10ths, the 15ths. Those are all multiples of 5. So all I have to remember is, I think I can do this. First of all, I did for some reason do the same ones again.